Section 6.6, titled Double Angle and Half Angle Formulas, has some really useful trig formulas. Let's start by looking at these two down here. The double angle for sine of 2 theta equals 2 sine theta cosine theta, is, I think, my favorite trig identity. I'm not kidding, I really do have a favorite trig identity. Now let's see how you get that. So let's look up here. It's going to come from the addition law, the sine addition law that we looked at in the last section. This you should have memorized. Sine of alpha plus beta, sine alpha cosine beta plus cosine alpha sine beta. Now, it's just a simple matter of putting alpha equal to beta equal to theta in that formula. So alpha will be theta, beta will be theta, the same thing. And so this would be sine theta cosine theta, right? And then cosine theta sine theta, right? Now, these two terms are the same, so they double up to 2 sine theta cosine theta, and that's all there is to it. Now let's see what happens when we play the same trick with the cosine addition law, cosine of alpha plus beta. So remember how there's a minus here, whereas up with the sine addition law there was a plus, so there's that switcheroo. Up here we had different functions, sine, cosine. Down here we had the same function, cosine, cosine, sine, sine. Anyway, we do the same thing. We put alpha equal to beta equal to theta in that formula. So theta for alpha, theta for beta. So cosine theta, so that'd be cosine squared theta, minus sine theta, so that'll be sine squared theta. So here's the double angle for the cosine, or at least one of the double angle formulas for the cosine. Now down here, you'll notice that there are 4 formulas. We've done the first 2, and there are 2 more for the cosine. So the cosine kind of thinks it's special because it has 3 double angle formulas. Anyway, let's see how those are obtained. So it's just a simple matter of taking the one that we just derived using the cosine addition formula, right? That's the one we just got up here. And then remembering that cosine squared plus sine squared equals 1. So that's the same as saying cosine squared is 1 minus sine squared. So if I replace this cosine squared with 1 minus sine squared and then clean up the algebra, I get 1 minus 2 sine squared for cosine 2 theta. Another way to approach that would be to do the substitution here, because cosine squared plus sine squared equals 1. Right, that's up here. That tells us that sine squared is 1 minus cosine squared. Okay, so we make that substitution. Okay, so that's right here. Sine squared is 1 minus cosine squared. And so the minus minus is a plus. Things double up, and we get this one right here. So that's how you get those 4 formulas. Now, like I said, cosine is kind of weird because it has 3 double angle formulas, whereas the sine just has the 1. And this is the one I like to memorize. It really is my favorite double angle, my favorite trig formula. Now I've turned ahead a couple of pages here. We're going to work towards the half angle formulas. So here's one of the double angle formulas for cosine. And here's another. Remember how cosine thinks it's so special because it has 3 double angle formulas, and here are 2 of them. So what we are going to do is we're going to take this first one and we're going to isolate 2 sine squared. So I bring that over here, right, and I bring the cosine 2 theta over here, subtract it. So we end up with this equation for 2 sine squared. And then, of course, we can divide by 2 to get this. Okay, so now we start with another one of the double angle formulas for cosine, this one here. And we, instead, we are going to solve for 2 cosine squared. So I just have to add 1 to both sides. So here's the other variant. That's this after you divide by 2. Now we're going to get to the half angle formulas. So what you need to do is take, in this case, 2 theta to be alpha. Okay, so alpha equals 2 theta, and then of course theta is alpha over 2. Right, so over here, theta is alpha over 2. And when we write that out, we're going to get sine squared alpha over 2 equals 1 minus cosine alpha over 2, right? Because theta is alpha over 2, and 2 theta is alpha. So 1 minus alpha over 2 equals sine squared alpha over 2. That's right here. Now to get the other half-angle formula, we're going to, again, do the same thing. Alpha will be equal to 2 theta. There it is, so theta is equal to alpha over 2. That substitution is going to be made here. So when we make those substitutions, theta equals alpha over 2, and 2 theta equals alpha, we get this equation right here. Cosine squared alpha over 2 equals 1 plus cosine alpha all over 2. That's one of the other half-angle formulas. Now, skipping ahead a couple pages, here's the 2 formulas that we just derived. We're skipping the tangent one. So these are the 2 that we just derived. 2 half-angle formulas, typed out very nicely. So now if we kind of expand this, so these are the 3 half-angle formulas that are usually written with the square, but of course you can take the square root to get sine of alpha over 2, and on this side you have plus or minus, so that's this right here. They're usually left in this form because then you don't have to futz around with plus or minus. You can just kind of bury that fact a little bit, and when you actually use them in this variant here, down here, you have to be kind of careful about which angle things are in, so you got to think it out if it's at plus or minus. But usually they're just kind of written this way. Now it turns out these 3 formulas are used an awful lot in calculus. I guess it's stated here. This one in particular has some really, really profound implications in calculus. But these are used a lot too, of course. That's it, except to remind you what is Alex's favorite trig formula. It is, with a drum roll, sine of 2 theta equals 2 sine theta cosine theta. But the cat Inky, she prefers cosine 2 theta equals cosine squared theta minus sine squared theta.